Greetings to everyone once again. Welcome back to my channel. In this video we'll be looking at the fourth question. So let's dive into each solution. The question goes, given that one of the roots of z cubed minus 5z squared plus 8z minus 6 is equal to 0 is 1 plus I. Find the remaining roots of the equation. So this is a complex function, and for that matter a complex cubic equation. We've been given one of the roots and we are asked to find the remaining roots. So let me write down what we have. We have z cubed minus 5z squared equal to 0, and we've been given one of the roots, 1 plus I. This was we've been given. So let's go straight to our notebook. Okay, so in order to solve this very question, one must have full or great fundamentals of roots of an equation, or roots of a function, and then factors of the function. So I'll take my time and take you through some practical examples so that you understand the difference between roots and factors. Given this, x squared minus 5x plus, let's say 6 is equal to 0, we can factor this to x minus 3, x minus 2. If we factor it to this, x minus 3 is a factor of this function, or this quadratic function, x squared minus 5x plus 6. Equally, x minus 2 is also a factor, but after equating, so now we know the factor. So these two are the factors of, let me call this guy f of x, so they are the factors of f of x, of that function. But if we go on further to equate, x minus 3 is equal to 0, or x minus 2 is equal to 0, implies x is equal to 3 or x is equal to 2. Now 3 and 2 are the roots of what? F of x. So in simple terms, the roots of the function are those values for the variable in question, when substituted, turns the whole function to 0, or makes the function defined as it should be. So usually quadratic functions, cubic functions, if we are talking about the roots, they are those values for the variable in the question, when substituted, changes everything to what? 0. So x equal to 3 is a what? Is a root, because if we substitute 3 in place of x into the function, we will get 0. But x minus 3 is a factor. That means it is divisible by x squared minus 5x plus 6. So if we divide x squared minus 5x plus 6, we get x minus, if we divide it by x minus 3, we get x minus 2. There won't be any remainder. So the factor will go into what? The function. It will divide the function without what? Any remainder. So x minus 3 is a factor. And how do we, if I've been given only x minus 3, if I was given only x is equal to 3 and I weren't given these factors, if I'm told that x is equal to 3 is a root of this, that means I'll say that x is equal to 3 is what? A root of f of x. Implies, this means that x minus 3 is equal to 0. Is what? This x minus 3 is what? A factor of x squared minus 5x plus 6. So we can deduce the factors from the roots, as we can equally deduce the roots from what? The factors. If you are given the root, you can bring the root to the what? To the other side of the variable, so that you obtain your what? Your factor. So if I bring the 3 there, I have x minus 3. So x minus 3 is a factor. So I can decide to divide it by this. Maybe I don't know what will come next. I don't know the other factor, but I know this. I can use my what? My long division to divide. So x squared divided by this, I have x times this x squared, this times this minus 3x. So x squared minus this 0 minus 5x minus this will give you what? Minus 2x plus 6. We divide this by this, you have minus 2. Minus 2 times this, you have minus 2x. Minus 2 times negative 3, you have what? Plus 6. Everything here tends to 0. And you have the quotient here. That means x minus 3 times x minus 2 will give you whatever you have there. So now, therefore, you can now say that your x squared minus 5x plus 6 is equal to what? X minus 3 multiplying the quotient, which is x minus 2. So if I'm given the root, I've been told that 3 is a root, and from that I've deduced the other root. So we will apply the same thing to our complex brother we have here. So let's still on this guy, x squared minus 5x plus 6, the factors x minus 2, x minus 3. They are factors, but this guy itself, if we multiply x minus 2 and x minus 3, we will get this guy, x squared minus 5x plus 6. So, and this guy, x squared minus 5x plus 6, the product is also a factor of this, because it is also divisible by this. If we divide this by this, we get 1, right? So that means it's also what? A factor of itself. Okay. So just as if we have maybe 2 times 3 times 6, the factors of let me use 4 times, okay, let's say 5. The factors of this number, which number is that? 2, 3, 6, 6 times 30. The factors of this is 2 itself is a factor, 2 times 3 is a factor, 2 times 5 is a factor, 3 times 5 is a factor, and 2 times 3 times 5 is equally a factor. You see, so 2 times 2 is a factor itself, 3 is a factor itself, 5 is a factor itself, 2 times 3 is a factor, 2 times 5 10 is a factor, 3 times 5 15 is a factor. So you can, their product, and 2 times 3 times 5, 2 times 3, which is 6, 6 times 5 is also what? A factor. So if you multiply everything, it's also a factor of 30. So we have all the factors here. One, from what we've been given, we have all the factors 2, 3, 5, 6, 10, 15 to 30. So you can deduce all the factors just by given if you are given only a few. I hope this is clear. So now since we have at least a little bit of understanding, if not a strong or firm understanding of factors and roots, let's now apply what little we know about factors and roots to solve this question. So here we've been given one of the roots. The root simply means that if we take this as f of z is equal to z cubed, so let's just take it this way, minus 5z squared plus 8z. So you can, if you want to do what I'm saying, define f of z. So let f of z is equal to z cubed minus 5z squared plus 8z minus 6. But we've been told that 1 plus I is a root of this. That means that z is equal to 1 plus I makes f of z. So makes f of z equal to what? 0. So in other words, f of what? F of 1 plus I is equal to 0. That's what we are told. By comparison, if we compare it to what we have top there, you see that z is equal to what? 1 plus I. And that's what we have here. So z is equal to 1 plus I is what? A root. This means that we can find a factor out of this. So by taking everything there to the other side, z minus bracket open 1 plus I is a factor. It's a factor of this guy. So it's equal to 0. So z minus 1 plus I is a factor of z cubed of f of z. So that means, so implies z minus 1 plus I is a factor of f of z. But we know that if we are dealing with complex numbers and all the coefficients of the complex number are what? Real numbers, then the root of a complex number and its conjugate are also what? The factor. The factor, if we have a factor of a what? Complex number, its conjugate is also what? Sorry, the root of a complex number. So the root 1 plus I, its conjugate is also a root. So z is equal to the conjugate of 1 plus I is 1 minus I. It's also a root. That means if we have f of 1 minus I, it's also equal to 0, because all the coefficients of this complex number are what? Real coefficients. So since the coefficients are real, then both the root and its conjugate are what? Roots. If we have a root of this complex number, its conjugate is also a root of the complex number. So now we have two roots. We have two roots of what? The complex number. We have also z is equal to this. So let's make a factor out of this one too. So z minus 1 minus I is also a factor. So now we want the factors, because now we have two factors. Z minus 1 plus I is a factor, and z minus 1 minus I is a factor. Why are we interested in the factors first? Because the factors will help us what? Factorize completely the complex function. Are we good to go? Okay. So now that we know that z minus 1 plus I and z minus 1 minus I are factors of f of z. Then their product, so their product, which is what, z. So let me bring out the 1 minus 1. So I'm just okay, so minus, let me just keep it that way. Let me have it this way, z minus minus 1 minus I. So I'm just isolating the i's, and then so the product, I want the product, so I'm multiplying this by the other one times, so this one too, I have z minus 1 plus I. Okay, so I have something like this. The way I group it, I hope you can see how I've grouped it. So if this is A and this is B, so we have A minus B. So here we still have our A, but this time around plus B, and we are multiplying. So I want you to see it in this format. So we have difference of 2 squares. So let's do the multiplication. Let's apply the difference of 2 squares. So we know that it will be what, z minus 1 square minus 1 square, which is called to what, you can take your time and do the multiplication, so minus I square, right? But we know that I square is the same as negative 1, so we have z square minus 2zi, 2z, this is 1, so 2 times z minus 1 times negative 1 is so plus 1 square, which is this, minus, this is I square, and our I square is what, negative 1, so minus negative 1. This will give us what, z square minus 2z plus 1 plus 1, so plus 2. So that means the product is what? Then the product is also a factor of f of z. So let's note the product, because I will cancel everything. My board is not all that big, so I cannot move. I can only cancel to make up some space for myself. So we have the third factor by what? Multiplying the two factors, as we already see in the case of 2 times 3 times 5, which was 30. We saw that 2 times 3 is a factor. Even though 2 is a factor, 3 is a factor, 5 is a factor, isolatedly or individually they are factors, but their products are also factors. 2 times 3 is 6 a factor, 2 times 5 10 is a factor, 3 times 5 15 is also a factor, and 2 times 3 times 5 is also what? A factor. So all these are what? Factors. And apply the long division. We know that if we divide a factor by the number, we will get what? a quotient. We only had a quotient, and we won't get a remainder. There won't be any remainder. So let's try and see. So now we have f of z divided by these two guys. So z divided by z square minus 2z. So minus 2z plus 2. So this in the number long division, we have it as our f of z is what? Z square minus 5z, sorry, z cube minus 5z square plus 8z minus 6. And let me just clean up this guy, make up some space for myself. My guy back again. So I have my z square, my divisor outside, minus 2z plus 2. My 2 and z are alike, that's why I introduced the this symbol inside. So z cube divided by z square, we have z times z square, we have z cube, z times this, z times minus 2z, we have minus 2z, z times 2, sorry, we have minus 2z square, z times 2, we have plus 2z, and the last one is just 0, there's nothing. So this minus this, it will go away, minus 5z minus 2z square, so negative becomes positive, so minus 3z square plus 8z minus 2z, we have 6z minus 6. So we have minus 3z square here. So minus 3z square divided by z square, we have minus 3. So minus 3 times this, we have minus 3z square. Minus 3 times minus 2z, we have plus 6z. Minus 3 times positive 2, we have minus 6. And you can see that it's just the same thing, subtracting the same thing from itself. So we have 0, this minus this 0, this minus this 0, this minus that is 0. So now we have this, the quotient is this. So we now know that our f over z divided by the z square minus 2z plus 2 is equal to what? The quotient, z minus 3. So implies our f of z will be equal to, that means we are multiplying both sides by what? This divisor, the denominator, so z minus 3 multiplying z square minus 2z plus 2. But we already know what this z square minus 2z plus 2 represent. But z square minus 2z plus 2 is equal to what? Z minus 1 plus I multiplying z minus 1 minus I. So we know that this is the same as this guy, so we can replace the product of this. So z minus 1 plus I multiplying z minus 1 minus I, we can replace it by, we can replace z squared minus 2z plus 2 by these two guys. Okay, so let me make out some more space and finalize everything. Our f of z is equal to what? Z minus 3. So in place of z squared minus 2z plus 2, we are now writing z minus 1 plus I multiplying z minus 1 minus I. So now we have this as our f of z, but we know that f of z, the equation itself is f, this guy is equal to 0. So this implies that z minus 3, z minus 1, z minus bracket open 1 minus I, sorry 1 plus I multiplying z minus bracket open 1 minus I is equal to 0. So if we have this equation, it means that we equate the individual terms to what? 0. So this means that z minus 3 is equal to 0, or z minus 1 plus I is equal to 0, or z minus 1 minus I is equal to 0. Which means z is equal to 3, z is equal to 1 plus I, or z is equal to 1 minus I. So we now have all the roots. 3 is a root of z cubed minus 5z squared plus 8z minus 6 is equal to 0. And then z is equal to 1 plus I, so 1 plus I is also a root, and then 1 minus I is also a root. Now let's go back to the question and see what we are actually asked to find. Let me close the solution for now. So here from the question, find the remaining roots. So the remaining roots are what? 3. The remaining roots are what? 3, and then the other one 1 minus I. We've been given 1 plus I. 1 plus I has been given to us. So we will conclude by saying, therefore, the remaining roots are 3 and 1 minus I. And that is it for the solution to question 4. See you in the next video.